Yeah.
I've never worked with him prior.
Well, thank you for joining us this evening. Before we start, I just have a couple general announcements to make. First, my name is Debbie Radis, and I'm one of the Quardev Business Development Managers. And a couple announcements regarding upcoming events. Our November SIG, we're going to have James Whitaker from Google. He will be doing a version of his Star West keynote, how Google tests software, We'll have it in a different location to accommodate a larger crowd, so please sign up early because space will be limited. SASQUAG, the Seattle area QA group, is having a one-day seminar on September 30th. And if you'd like, you can pick up some information at the registration table downstairs or check their website. And finally, PNSQC, the Pacific Northwest Quality Software Conference, is coming up on November 10th, and registration is open.
October.
October 10th. I apologize.
Oh.
Thank you.
Yes.
Yes. Yes. And I'll turn it over to Joy for the presentation. Thank you.
Thanks.
Do we have a section of general announcements? Is that at the end?
I believe it is. I'm usually downstairs at the registration table, but I think we can open it up for general announcements.
Yeah, I think they usually put it at the beginning, if I recall.
Yeah, that's
Go
why.
ahead. You've got an
I
announcement.
Yeah.
What a surprise.
What a surprise, yeah. Yeah, my name is Alexander Amaya. I'm a QA manager at Amdocs. And I'm currently looking for a senior quality engineer. And I have the qualifications for that with me. If anybody's interested or you know of anyone, please come in and see.
Is that AT&T?
No, at Amdocs. Interactive. We're in the Seattle downtown. And it's in Elliott Avenue. So if anybody's interested, let me know.
Anyway, go ahead.
Hi, I'm George Riley. I'm a dev lead at QASIG. We're a small company in Pioneer Square. We're looking for an automation tester.
Anybody else? Okay, I'll get started. My name's Joy Schaefer. I work for Quardev. I'm currently on contract at Washington Dental Services. And I'll tell you a little bit about who I am and why I'm here, and I want to find out a little bit about why you're here. So why am I here? I keep asking myself that question. Why did I sign up for this again? But I have 20 years in the software industry in testing. Most of that time has been in test management. I've also done consulting and training gigs for quite a number of those years. I have learned a lot about what to do and what not to do. I've worked with some really successful teams along the way. I've worked with some teams that just had dismal practices and were really, really struggling to get their software out the door. So this is sort of, this whole presentation is sort of the culmination of some of the things I've learned in my 20 years of managing test teams and working also in the trenches on test teams. And I couldn't cover everything, so I tried to focus on sabotaging quality. I'll talk a little bit more about that in a minute. But I wanted to find out, just from a couple of you, because I don't want to take too much time, but I wanted to find out why you here. What were you hoping to get out of this presentation? Anyone? I know my coworkers just came to heckle me.
That's right.
Anyone else?
I come to these because it's a way of plugging into other people that do QA. So,
Okay.
So I come to almost all of them.
Okay. So networking.
Yeah,
mainly?
really.
Yeah.
I found the overview on the about some of the ongoing problems that development projects are facing as far as acquiring debt. That was so the topic was very interesting.
Okay. Okay. Good. Anyone else want to say anything real quick?
I want to follow up on that, but also I'm here because I find that test is a very
image or discipline compared to software development. And so I'm curious what people do and how things are shaking out about how we do quality and keep measure the quality, keep it going.
Okay, good.
I'd like to sort of echo that. I mean, because I find more and more that first question, what exactly are we doing, those people of us that work in QA? We don't really know I don't mean to say that people don't know what they're doing, but there just seems to be so much variance in what the process is and what we're actually trying to accomplish.
Yeah,
So the more information I can get from other people, the better.
okay, great. Okay, so I don't know how many of you read the abstract. I've narrowed the focus of it a little bit. I've already given this presentation once, about 6 weeks ago at Google, and I decided it didn't fit in the time frame that I have for it. I'm going to be giving this presentation at Pacific Northwest Software Quality Conference coming up in October, and I believe I have 45 minutes for it there, and I'm supposed to have question and answer. So I think at Google, I barely fit it into an hour, and I think that the stuff I cut off was probably the least important stuff. So I basically tried to focus on the sacrificing short-term goals for long-term goals, because that's the biggest problem that I see companies do. And if you continually sacrifice short-term for long-term goals, you're probably never going to be very efficient at developing software. So that's basically the focus of this. I'll take a couple of questions now, but once I get into the
No,
meat,
it's that you keep saying sacrificing short-term for long-term,
Oh.
but your thing says sacrificing long-term.
sorry.
Yeah, you're reversing it.
So thank you. So nothing like teaching testers. They're more than happy to tell you everything around your presentation. But no, thank you. You probably catch me in a couple other things too.
I have a different issue.
Okay, go
If I
ahead.
offered to help you move the table, would you move to your right so I can read your
Right in the
screen?
middle.
Oh,
Thank you.
sure. Yeah.
Oh, great, this is perfect. I just
Volunteer everybody else for it.
One of the issues is I need to stay in the camera range, which I was told was.
Oh, there's a camera
Oh,
too.
so-
Okay.
Okay.
So hopefully I'm still within
You're
camera
fine.
range.
You're fine.
Okay, so I'd like to, for the most part, hold questions unless you have something really burning, and take questions at the end, because I want to see how long it's going to take me to get through this. Like I'm trying to get my timing down on it. So, okay. So the things I'm going to cover are here. You guys have, the slide's been up probably long enough for you guys to have read that, so I'm not going to read it to you. So most of the time, nobody actually sets out to sabotage quality. Things just get away from them. Okay, so one of the first things, or one of the main things, especially if you're in test, you notice this, that gets sacrificed when you're looking for short-term goals rather than long-term goals is investment in test, and usually specifically investment in test automation. We don't have time to automate, we just need to test it and get it out the door. So I'm going to talk about that for a little bit. So how many of you know what a BDT is? Okay, good. The last place I gave this speech, a lot of people didn't know. No, I'm joking. I just had one guy argue with me about the validity of a build verification test, which kind of surprised me that somebody would even question why you would want to test the code, make sure that the code met a basic level when you first got it before you actually started going on a full-blown test pass on it.
Because you unit tested it very well.
Well, maybe. Although, actually, okay, so let me just talk a little bit about this, and then I'll recap. One of the teams that I started working on, well, I've worked for a lot of different teams over the years. One of these teams, and you'll hear a lot about them in this presentation because they sure know how to sabotage quality. When I started working for them, their BVTs had a passing rate of usually somewhat less than 60%. Every day, day after day, this has been going on for years. And so, of course, I asked the question, BVTs should typically pass 100% unless somebody really breaks the build. So I'm like, well, are their BVTs too complicated? But, what's the problem here? Well, it turns out that it was a system that was very dependent on a bunch of other systems. And a lot of so it was big company and they were dependent on all these other teams at this company, a lot of these other teams did not keep a reliably functional system for them to integrate with. So if this other team was down, then that particular BVT would break that day if their integration environment was down. So that was part of it. Part of it was simply that this team had lost quite a few people from the test team because they were bleeding pretty badly at that point in time. It wasn't a very fun place to work. And they just didn't have anybody to maintain those test cases until they hired and backfilled. So that was part of it. And part of it, I think, was just a loss of focus on, what is, why would you want your BVTs to pass 100% every day? You really want to be able to tell if when a developer checks in code, you want to be able to tell right off if the basic functionality of the software is still there. So it took us a long time, but we eventually got the BVTs passing 100% every day unless somebody really broke the build. So the things that you should have to do that is you need BVTs that are robust. And by robust, I don't mean extensive. You can start with just a real small set of BVTs and add on to it if you need to. But they need to be reliably functional. That's what I'm talking about by robust. You need to make them not dependent on other systems as much as possible. So build emulators for all those dependencies that you have out there, or most of those dependencies. I have another slide on that, so I'll cover that more later. They need to be definitive. If the test fails, it fails because of the code, not because there's a problem with the data, there's a timing issue, there's a problem with the network, there's a problem with the setup, etc. Now, some of those things you're never going to be able to cure entirely, but for the most part, your test cases, all of your test cases should be definitive, and especially your BVTs. And I've already said you can start with the basic test and add on. So we eventually fixed that team that we were on. So automated BVTs are basically essential if you want to do a good job at continuous integration. So continuous integration or near continuous integration is the idea that the developers are going to, as soon as they do their little piece of code they're working on, they're going to check it into the main code and it's going to get integrated with everything else. And the reason you want automated BVTs for that, what you really want is a system that does automated build, deploy, and BVT. So the developer checks in his code, hits the build thing, builds it, it automatically then goes into the deployment system, which deploys it to the environment where the BVT is going to run. The end of that kicks off the BVT, and the developer gets an automated report, however long that takes, an hour later, or depends on your software, how complicated it is, that tells him whether or not he broke the build. And then he can pull his code back out if he did. If you do continuous integration is a best practice. I worked on a team once that only integrated their code about once every 2 months. And I was actually shocked that they ever managed to ship at all. They shipped about once every 4 years, I think. Conversely, I've worked for a team where we didn't have completely continuous integration, but we did integrate, we did do the auto build deploy BVT twice a day. It was a global team, so we had people working, we had testers in India, developers in Moscow, and then a core team here in Seattle area. So we did, in the morning, we took a build to take all the development that the Moscow folks had done overnight, and in the evening, we kicked off a build so that they could start with what our coders had done during the daytime. And that team was the most efficient team I've ever worked on. We got to where we could deliver software to the day. Once we even delivered a week early because our partner asked us to. We're like, no problem. And they were, their jaw basically hit the floor because we were that good. But it wasn't me, it was the team, and it was really the processes. So So in order to have continuous integration, you pretty much have to have an automated BVT system. Believe me, if you're manually running build verification tests twice a day, you're going to go batty. You're going to lose your entire test team because they're not going to be able to do it. Who wants to do that? So, okay. Another best practice that often gets pushed off because we don't have time to do it is unit testing. There's been numerous studies that have shown that if you do an adequate job of unit testing, you will ship faster, you will have cleaner code, you will be more reliable, your code will be better designed because when the developers think about designing those test cases, they'll often come up with a better way to design their code to accommodate the testing. One of the nice byproducts is having your developers do formal unit testing is the developers will build things so that they can test with it. They'll put in test hooks, they'll build mock objects, they'll make all kinds of tools or acquire all kinds of tools for themselves to get their jobs done. If you have a good relationship with your developers, you should be able to share those tools. And then another thing that comes out of unit testing is generally a better understanding by the development team of what testers go through. A lot of them don't realize the difficulty of testing, all the different things you have to think about, until they start to do it themselves. And then they go, oh, gosh, how am I going to test this? It is a best practice. Most teams that do a good job of it will ship, will be more efficient developers. So so the question is, one of the questions you might have is, okay, if you don't do unit testing, if you've never done formal unit testing, and maybe it's spotty amongst your team, some people do it, some people don't do it, everybody does it at a certain level or not. Nobody really knows how much unit testing there is. That's probably the way most teams are. How do you get started? Well, I think the first thing you'll need, and that's the case for a lot of these things, is support from management. Because there's always going to be a few people that go, oh, I don't want to do that. So management has to basically say, this is a best practice, we're going to follow it, we're going to unit test, and this is how we're going to do it. So one of the teams that I was on had legacy software. None of it had been unit. There was no existing bed of unit test cases for any of it. And they got started by saying, okay, from this day forward, all the new code we write is going to be unit tested. All the developers are going to need to run this code coverage tool on their unit testing and see how much of their code that they've tested, and they're going to have to hit, I think we might have started with 60 and then went pretty quickly to 70% of code coverage in unit testing because they were actually doing a pretty good job. And people grumbled at first, a couple of them did, but pretty quickly it got to be a contest, and some of the developers were checking in code that had passed the unit testing by over 90% on check-its. So that was pretty cool. We were doing Scrum at the time, so it was announced in the Scrum meeting, what percentage of their, so-and-so did a check-in and it passed it, 86%. Everybody's like, yay! So we within 4 months, we went from 0 unit testing to having 16% code coverage through unit testing on this software. So it wasn't just all new code, it was every time a bug was fixed. They had the unit test bug fixes as well. So it's a way to get started if you haven't done unit testing.
Did you perform any injection point analysis to say, if somebody finds a bug that was when they were doing functional testing, hey, this should have been caught in a unit test type thing? Because what's interesting on that is, I find that if you show developers that, hey, you could have caught this, now instead of having to do work fixing a bug that somebody else filed on behalf of their code, they can continue developing new stuff instead of having to fix old stuff. And that's another game I think is valuable to play with.
That's a good point. I've actually never worked on a team that did bug injection, but it sounds like a pretty interesting concept. Might be pretty useful. Management support. So I'm not going to say a whole lot about automated regression tests. I will say if you have a regression test suite that is automated, it's going to make you a lot more agile. You'll be a lot more willing to take risk with your code, to maybe refactor something or make big changes, because you don't have to spend all this time with this army of people manually combing through it. You can just hit a button and find out if you've broken anything, and then if you've broken anything, maybe you'll decide not to implement that code, or you need to do more work. But it can make the whole thing a lot faster and a lot easier to test. The other thing about automated regression testing is machines are very good at doing the same thing over and over and over again, and people are not. And believe me, if you're doing manual regression testing and it's the 50th time you've gone through this test suite, you've never seen this particular test case fail, your boss is breathing down your neck to sign off because you were supposed to have shipped last week, you're going to go, oh, it's not going to fail, and you're going to mark it pass. And guess what? Maybe that time it would have failed. And then when people come back and say, how did you mark this pass? And I must have missed a step. I don't know. It's regression testing generally doesn't lie. You sometimes get false positives, but you generally won't get false negatives if you've done a good job of designing your regression tests. So, okay, the last thing I'm going to cover in the testing investment in testing suite is the ability to emulate external components. The idea of breaking things into modular pieces and testing them separately has been around a long time. Used to be done with drivers and stubs, and some, probably in a lot of cases still is. A lot of people are using mock objects these days, object-oriented programming. If you're emulating an entire module, something somebody else has built, it's usually called a simulator, an emulator, sometimes a sync. If all you do is just send stuff to it, it's a sync. So one of the things to keep in mind is you don't have to build this whole complex functionality that your partner has. All you need to do, you don't have to build something that goes and fetches data from the database and does whatever it is that their software does. All you usually need is something that takes your proper input, maybe checks it to make sure that your input is proper. That's possibly something you would have built anyway as a testing tool, and then gives an appropriate output back to your system, right? So you can start pretty basic and then embellish as you go on. The nice thing, so you don't want to get too complicated because you also have to keep it up to date. If the component you're emulating changes, you might have to maintain your tool to continue to mimic the component. So one of the ways you can save time if you're in a big company and there's a lot of other teams is you might find another team that's already built an emulator for the component that you're trying to do, and you can borrow it from them and customize it for yourself. We've done that. Emulators are really handy for VBTs if you're dependent on other people and they don't keep their integration environment clean. So that you can always pass BBTs, or if they're down, you can still keep testing or what have you. Lots of times people don't think about it till they get to performance testing, which tends to happen at the end of your development cycle. And then all of a sudden somebody realizes, our partner doesn't have a performance environment that we can pound on. How the heck are we going to performance test our system? We need to build something that will let us, pound on it. So if you've already, if you built your emulators up front, then you have them. You have them throughout the whole cycle of the testing. You can use them in your automation any way you will. It might seem like a lot of work. I've worked on a number of teams that have built emulators, and my experience with it has been not a single time. There's always been debate at the beginning. Are we going to do this? It's too much work. How time consuming is it? Is it worth it? Not a single time have we built an emulator and then gone, oh gosh, that was a waste of time. Every single time we built an emulator, we've got, oh, I'm so glad we had this. If we hadn't had this, what would we have done when this happened? No, so you may have had a different experience, but my experience with building emulators has been that they're extremely handy and generally worth the investment if you don't get too complicated with them. So, so the whole summary of the test, invest in test, invest early, invest often. It'll make you a lot more efficient team in the long run. So we'll move on to software quality. Now on this slide specifically, I'm talking about bugginess, because software quality is a big, I probably should have just called the slide bugginess. Maybe I'll make that change before PNSQC. So the idea is, one of the things teams do to save time is they'll put off fixing the bugs. They'll let people write all the bugs, and the developers work on new code, and they save all the bugs to the end, and they fix them at the end. And for some reason, there's this concept that this will save you time. But studies, all of the studies show that the closer to the time that you find a bug that you fix it, the faster it is to fix, the easier it is to fix. The cleaner your code is to start with. You're not putting buggy code on top of buggy code, and you'll ship faster and be more dependable. So there's not a good argument for saving your bugs up to the end.
I have a comment against that. I mean, especially with Agile, that whole concept of Agile is building the slightest, the smallest slice end to end, and as you add the other elements to it, you continue, you're finding more about your solution. So, sometimes that doesn't discover all the bugs because you have a clean slice, and as you're putting all the pieces together, you're finding more about the issues with your software, and then sometimes you collect those at the end to try and see, because you have the entire solution. Basis with waterfall, you have the entire solution and you can find them right away. But it's not having the entire solution at the beginning is it gives you that, that problem. At which point on the line you're gonna find those bugs, or the thin line?
Well, there's the bugs that you find initially, and then there's the bugs that you find when you start doing integration. So you can't really find the integration bugs until you just get to the integration phase, but you should integrate early and often too. Okay, but thanks for the comment. Another thing you should think about doing to maintain your code quality is to consider refactoring the buggy areas of your code. So lots of times, especially with legacy software, there's particular parts of the code that tend to be really buggy. These tend to be the complex areas of the code. If you run the cyclomatic complexity tools on them, you'll find they're the ones that are spiking. They're the areas of the code that no developer wants to touch with a 10-foot pole, because they know if you poke it here, it's going to bulge over here. You fix one thing, two more things break. If a lot of people are spending time and resources because of these bugs, either be it the customer support people, or it's a nightmare to test, it's a nightmare to code, it's a nightmare to maintain, it might well be worthwhile, it might make economic sense, their higher return on investment, to just yank that whole piece, build another thing that has exactly the same functionality, and put it in there. Some of the things you might want to consider when you think about refactoring are, is this particular code going to be even, or technology that you're using for that piece going to even be supported in the future versions of Windows, future versions of your database software, future versions of whatever other software you happen to have that it might be dependent on.
Successful that they could refactor? Because I've yet to be at any place where they've been able to refactor anything.
Really? Yes. The project I'm on right now, we just finished refactoring something. It's no longer written as a component. It is now a bunch of Windows services.
I think that kind of comes into play when a lot of times developers are given incentive to be productive. they think. So productive means how much do I produce? It does not necessarily tell you how much you have to reproduce and all that kind of stuff. And if you can get their mindset changed to being effective rather than productive, all of a sudden they start thinking about the quality and they will see more value in that.
Yeah, refactoring does tend to be a really hard sale for senior management because they're not seeing the value. What you have to do is show them how much pain it's causing them, and if they really want that pain to go away, they have to refactor this particular component.
I had a question.
I'll get him first and then you, and then I really kind of want to move on.
Yeah, refactoring is based on having solid unit tests. And so it's sort of a circular feedback into your test cycle.
Yeah, you'll find a lot of these best practices really support each other once you start doing them. Yeah, and
my question is like with refactoring, like let's see, we do refactoring, like you refactor this whole UI with this new technology. Let's use an example, Grid, and here you spend up like a couple $1 million updating it, and then 2 years later, that technology is now your old technology. So what's your comment about that continued refactoring? If you say short-term, long-term success, how?
Well, you want to. Everything is different, and you may well look at what you've got and decide you're going to live with it because in 2 years you're going to get rid of that component anyway, and it's not worth putting 6 months into now to fix it or whatever. But if you look at the life cycle of your component, if you think you're going to need it for another 5 years and you're spending, you really can, if you get enough information, come up with a formula that will give you the return on investment. And if your return on investment is 3 years out and you think you're only going to use your component for 2 more years, then yeah, it probably doesn't make sense to refactor. So, a couple of techniques that you want to think about, or that you can use to help improve the quality of the software that I've seen used effectively are what's called a quality release. That is, you do an entire release that is focused just on fixing that huge backlog of bugs that you ended up with. If you don't fix your bugs as you find them. That's one of the things I forgot to mention. If you don't I've actually been on teams where the beginning of the project, we had like almost 2,000 bugs left over from previous projects for us to go through and figure out, do we need to fix these? But and it's a nightmare. You can do a quality release where you fix the bugs and maybe refactor and try not to let, marketing will always try to get a few features in there, but try not to let them get any features into your quality release so that you really can usually, if you focus only on fixing bugs, fix a lot of bugs in a single release. So,
what about all the bugs you introduce when you fix all those bugs in your quality release?
Well, hopefully you'll find those and fix those immediately, right? Another thing that we've done effectively on teams is implement a bug jail. That is, any developer that had more than 8 bugs, 5 bugs, 3 bugs, you pick your number, wasn't allowed to develop any new code until he fixed their bugs. They had to be below the threshold, otherwise they were in bug jail. And we were doing Agile at the time, so every day they'd go, oh yeah, John's in bug jail. And developers got embarrassed. They would keep track of how many bugs they had, and they kept, you'd notice all of them kept it like right below the threshold for the bug jail. Then we'd lower the threshold as we got closer to release. But it was a good way to keep the bugs out. I'm gonna cover those other topics, I think, in a different slide. Okay, I'm gonna talk about the ability to maintain your software or your service. So one of the groups I worked with, when I first started working for them and saw what they did, I came up with an estimation, and this was just through my observations, that they were spending, as a team, about 20% of their available time on actual productive things, on actual new features, or to support customers or support partners. They were spending probably 80% of their time on what I would consider maintenance things. And you're probably thinking, my gosh, 80%, how can this be? Well, their live site was not in good shape. So they had a lot of live site issues. Every time there was a live site issue, it was like all hands on deck. People just got yanked off of whatever they were doing and put to fix the live site. So a lot of focus on fixing the live site. Once we finally got the live site stabilized and in reasonable shape, then that went down dramatically. Another big time sink for this team was the deployment engine. When the deployment engine had been built to deploy to one environment. And we were deploying to, when probably all of us had done like 8 or 9 different environments, which if you're on a big team, that's not unusual. You've got maybe a specific BBT environment or pre-test environment. You've got a project environment, maybe a couple different projects going on at the same time, maybe a couple different project environments. You probably have a performance testing environment. You might have an integration environment. You might have a staging environment and a live site or production environment. So you're going to be deploying a lot more than just a one environment. And the system that they had set up, every time something changed, they had to edit it in all these different places. And of course, it was a manual process. Something always broke. Every single time they did a deployment, they would spend hours troubleshooting the problems with the deployment, trying to get the software to work. Because they didn't do any investment up front in designing a decent deployment system. And we could never sell management on a project to fix the deployment system, even though it probably would have paid for itself within a couple of releases. Another thing that took a ton of time was they had this elaborate setup of documentation that they had to have meetings and everything had to go perfectly, that all this deployment documentation was required by the department that actually did the actual deployment to the live site, because his team had such a poor record of being able to do things well. So everything all the I's had to be dotted and T's crossed with these huge documents before anything got deployed. And it still didn't fix deployments to the production environment. So, let's see, there was one more thing. Live site issues, deployment, the lab. The test lab was in deplorable shape. So there were a lot, machines would go down on a regular basis, and people would spend a lot of time troubleshooting these troubleshooting issues that they should have never had to spend time troubleshooting in the first place in a well-maintained lab. And of course, there was no logging built in to the software anywhere, so nobody could really tell what was wrong when there was a problem. It was a gas. So developers are pointing at the IT guys are pointing back to development. And meanwhile, everything was burning down. We eventually flipped it around on that same team. It took about 1.5 years to do, and a lot of work, but we did it. So one of the things we did was invest in the physical infrastructure. I happened to take over the test lab. I was given the performance test team, and I realized how dependent the performance team was on the hardware and how bad and unreliable the hardware was. And then the guy that was managing the lab left at that time, so I went to my boss and asked if I could own the lab too. So he gave it to me, didn't think anybody else wanted it. And the first walkthrough of the lab, I discovered that they had routers in there that were more than 10 years old. They had fully 50% of the machines in the lab were past end of life. And some of them had not been patched in years. And I was just astounded that they'd been able to get away with that at that particular company. And we implemented a process. This is kind of a just-in-time story. I said, okay, we have to patch at least on a regular basis. And we've got new hardware too, but that was, and the argument I got, this team was continually in crisis mode. They would never let them have downtime to patch, and I'm like, that's ridiculous. You have to have time to maintain your hardware and your software, your underlying infrastructure. So I just over-communicated, once a month on Thursday morning from 6 a.m. to 10 a.m., lab is going to be down because we're patching. And it actually worked. It went really smoothly. It worked really well. I mean, I guess everybody understood on some level that we had to patch. And maybe nobody wanted to argue with me at that point by then. But what happened was probably only about 6 weeks after we had done this, I think we patched at least once, but maybe twice. Somebody at the company, nobody on our team, but somebody at the company accidentally opened a channel to the open internet from our lab, and security discovered this and shut us down, like immediately, pulled the plug on our lab. And then they came in and did an audit. They turned us back on within 24 hours because all of our patches were completely up to date. And I was just like, phew. If that had happened 2 months earlier, we probably would have been down for months. Well, they dug very deeply. If they looked under the covers, they would have seen probably all kinds of stuff. But luckily, they just looked to see how well we were patched. So, so maintaining good hardware, as far as I'm concerned, it's not. You shouldn't even argue about it. Just do it. If you look at how much you pay the people, that's your big expense. If you've got a development team working for you, your big expense is those people's salaries. It's like, 2 or 3 people spend an hour arguing over how much RAM they can afford to put in a machine. You've already paid for the RAM. Just do it. So I saw an article a couple weeks ago that said for an average developer, they estimated a salary of $100,000 a year is what they used. Up to 7 monitors would pay for themselves within 6 months. So, can you imagine 7 monitors all lined up on your desk? So if you don't have at least 3 on your desk, you got to go to your boss and get another monitor. Maybe it'll make you more efficient. That's what they said. Okay, logging. Logging is something else that tends to be overlooked, maybe not invested in. There's a number of different reasons to log. One of them is so that you can find issues with your software. Sometimes they'll implement logging specifically because they have a problem, they can't figure out what's going on, they have to implement logging so they can get enough information to fix the problem. Sometimes it's more of a long-term thing. You can implement logging just to see how things are reacting, how many, or maybe not necessarily logging, but sort of logging and metrics together. You'll want to use to figure out, how quickly is our customer base growing, what are their usage patterns, how long is it going to be before our live site melts down if we keep growing at this particular pace. Another reason to implement logging is to support your SLAs, your service license agreements, service level agreements. That usually often you have with a trading partner. You'll promise that you're going to have 95% of your transactions happen within 5 seconds or something. Well, you have to prove to them that you actually are having 95% within 5 seconds. So you have to do some logging and metrics around that so you can get that data. So my recommendation is that you build at least the infrastructure and your policies around logging up front. You don't have to build all the logging, but you need to have an infrastructure in place, plan on logging, and you'll use it. You can get a lot of use out of it. The last thing I'm going to talk about on this slide is metrics. It's one of my favorite things to talk about, but I'm not going to tell you what metrics to do, because that's not what this presentation is about. There's a lot of different, the main reasons to measure things, to track metrics, are to figure out where you can make improvements. So you can track metrics for your software. You can and should also track metrics for your processes. What are our processes actually working for us? Could our processes be better? Another thing that a lot of people don't think about with metrics is you can use them to drive behavior. And sometimes if you don't pay attention to your metrics, or if you've got weird metrics, you'll drive strange behavior. So one of the teams I was working on, my boss wanted me to do some metrics on our software automation, and I wasn't exactly sure what the best metrics were. So I sent out an email to this alias at our company and said, what what's your experience? Who has good experience? What would you recommend for software automation? I got about 3 people that gave me legitimate answers. I got about 20 people that were appalled that my boss wanted me to get them this information, and they all said that, don't give it to them, they'll use it against you. Basically, was the response I got. So with this in mind, I decided, okay, I'm not going to have them report what percentage of our test cases are automated, because there's always going to be a certain percent that we are probably never going to automate for whatever reason. I'm going to say, identify what we want to automate and tell me out of everything we want to automate that we think makes sense to automate, what percentage of that is automated. So that's what I had them report back. And things went pretty well for a while. We went from 0, because it was a brand new product, to about 95% automation in about 6 months or so. And then it stayed there, it went up and down a little bit. 95% of all the test cases that we want to automate are automated. Well, it took me probably longer than it should have, but several months later I actually looked at, okay, what percentage of all our test cases are automated? And lo and behold, it was only about 55%. And I'm like, okay, that did not feel right to me. I was pretty sure we wanted to automate more than that. So I changed the statistic. I still have them report the old statistic, but I also have them report on what percentage of total test cases were automated. And lo and behold, you can see just changing that metric. Here's our ramp up. Here's our steady state. Here's where I changed the metric. All right?
So is the takeaway here that you should change the metric in the middle? That's what I'm hearing.
Well, actually, one of the takeaways is don't be afraid to change your metrics. And don't be afraid to look at them. Are you really measuring? And also pay attention to the behavior that you're driving with your metrics.
Did you have any requirements for how actionable test failures were? If you had an automated test failure overnight in the lab, and the person who wrote the test, came in and said, okay, there's a failure, here's some information. Did you look at how actionable the information is? Or if you just have to load up the product and a debugger and look in detail to find out, okay, this is what's going on. Is it a product bug, right? Automation?
No, we didn't get to that level on the automation. But that's an interesting idea. Have you done that?
Yeah, I've been an advocate for having test failures be as actionable as possible. I can't get 100%, but try to put in good information and then logging and exceptions, customer exceptions and stuff,
Right.
whereby if you get an exception, you say, okay, it's run from this module owned by this team.
Right.
And here's the information,
Right.
and in another context, or we're missing some
Right.
context information here, so maybe I want to catch and rapid rethrow with more context information. And the idea is to make the automated tests more
Right.
actionable.
More,
Otherwise, they can get very expensive.
Right.
And
Right.
even you'll wish you hadn't automated them in the first place because you think, oh yeah, they're covered, they're all failing.
Right.
But actually, you're not testing the product.
Right. Okay, good. Makes total sense to me.
Mhm.
I'm gonna need you to go ahead and come in.
The office space.
Yeah, that's right. That little clip from Office Space. I actually, that clip and this particular picture were both sent to me by testers that I was managing on teams where our working hours were getting out of control. And I was just glad that they trusted me as a manager enough to send this to me. I did not send it to the boss I happened to have at the time, however, I didn't think he would appreciate it.
Because of the last bullet?
Yeah, probably, yes, yeah. So, you're at the end of the project, you're behind schedule, it's too late to bring on more people to make a difference. What do? Well, make everybody work more hours. It seems logical, it's very common. If you have a healthy team and you truly are at the very end of your project, it's probably not going to do that much damage. It might help you ship a little faster. I did see a slide on the internet when I was researching for this that showed that working a 60-hour week spike for like 3 weeks you got higher productivity for those 60 hours, but over the next 3 weeks after that, your productivity was lower, so that over a 6-week time period, you actually got less productivity than if you'd worked steady state in those 6 weeks. So I would say only do it if you've really only got 3 weeks left in your project and you really need to. And then after that, expect everybody to be on vacation for a while, or not working as hard, because it really will happen. I've seen and worked on teams where people worked hours and hours and hours. One of the projects I was on early in my career, we literally, gosh, I had breakfast, lunch, and dinner at work 6 days a week, and Sunday it was only breakfast and lunch. And that went on for months. And what happened was, after we released, I think it was like version 1.2 of our software, and we'd all been working like this for a long time. Some other people have been working like this for years, for the most part. Everybody quit. Everybody on the test team, there were 7 people on the test team, 8 people on the test team. Everybody quit except 2 people, me and the new guy. And so that was my first management job. They made me manager at that point in time. But my first job as the new manager was to refuse to work those hours. And I don't know why some managers have the idea in their head that more hours is better. More hours leads to lower productivity. Study after study have shown that more hours leads to less output, not more output. Now, interestingly enough, they've done, in some of the studies they've done, people that are working more hours think they're being more productive, but when they actually look at the output compared to the team working at steady state hours, they're less productive. They just think they're being more productive because they're there more. It also, so not only does it not make you more productive to work those hours, it leads to job dissatisfaction, burnout, obviously, high turnover, and mistrust of management. So I have numerous horror stories, and I won't go into them. But if you want to catch me afterwards, I can tell you something.
One thing I like to look at is what am I doing when I'm working long hours, and most of the time, teams, when they're working long hours, are working in a reactive mode. You know, there's all these bugs they got to go take care of. There's all these tests that failed. They got to rerun them. Whatever it is, that's a very reactive thing. As a manager, what I work a lot of hours, but I have fun doing it because I'm working on proactive stuff. Like, what can I invent so that the team has it easier for them next time? And it's very satisfying in that sense. So,
Yeah.
So what I'm trying to do is make it so they have less reactivity in their work, and so my overtime doesn't hurt.
Right.
There's voluntary overtime and you must work this weekend.
Right.
Which I think is what she's talking
There's
about.
a huge difference. And one of the things that I know that I saw this, and I looked all over the internet for it and could not find the study where I saw this, but earlier in my career, I saw somebody had done a study where they discovered that if you look at average hours worked over time and productivity, it was a bell curve, right? So if you work 10 hours a week, you get this much done. 20 hours a week, you get this much done. 40 hours a week, you get this much done. If you're working 80 hours a week, you're only getting done what, week after week, you're only getting done what 20 hours a week did. Now, Ford did extensive studies. He did 12 years worth of productivity studies way back at the turn of the century when he was building, on assembly line. And that's where the 40-hour work week came from. They actually lobbied Congress. And he didn't do it because, at the time, people were working a lot more than 40 hours a week. He didn't do it because he wanted to improve people's lives. He did it because that was where he made the most money as an entrepreneur, was when people were working. People were most productive in his assembly line at 40 hours a week. Now, I personally think it depends a lot on the individual and the type of job they're doing, what their sweet spot is. So I worked with a woman who I swear was happy at 55 hours a week. And that may change for that person over time as well. But some people probably get up to 35 hours a week, and that's about it. In fact, when France lowered their work week from 40 to 35 to try to get companies to hire more people because they had such a big unemployment problem. And it backfired on them because they discovered people got more done in 35 hours than they got done in 40 hours. So they didn't need to hire anybody, they just got to pay everybody less, right? Or, maybe not, but.
Just convince them that sleep is overrated.
I can talk about that too, but I won't. Okay, so one of the things I want to talk about is I've been going on about what are best practices and what are all these horror cases of people and how did we fix it. But really, when it comes down to it, people never set out purposely to sabotage quality. I've never seen anybody say, "Oh, I'm gonna make sure they never ship again." There's a lot of different things that companies do, sort of accidentally, that sabotage quality. And one of the things is misdirected reward systems. Software development, unless you're like a one-man show, is a team sport. There's usually multiple people, sometimes a fairly large team, all working together. What you want to do is figure out how to reward teams. I have never actually worked for a company that had a structure in place to reward teams. I've worked for individual managers that valued team work and tried to reward teams, but they had no real support from the structure of the company. A lot of companies actually reward individuals to the detriment of the team. They pit individuals against each other for this small little pot of gold, and you're sort of rewarded if you stab somebody in the back because it'll make you look better. And that's really kind of the worst way to try to develop software, because you want people to be working together and you want to reward them for working together. Luckily, if you're on an efficient, highly high performance team, it's a reward on its own. Some of the best times I've ever had at work have been working on a high performance team. Whether or not you actually get along all that well with your coworkers, it's still extremely rewarding to be on a high performance team. And usually if you're doing well, you tend to get along with everybody anyway. So some of the tactics, you're probably thinking, okay, well, we know the best practices. You've been telling us about the best practices, but we're professionals and we come to these kind of things and we already know the best practices. So what we want to know is, how do you get people to follow them? That's the trick, right? So here's some of the tactics that I've used, and everything is situational. So different tactic for different situations. The first thing is you need to know what the best practices are, otherwise you're probably not going to be following them. So if you don't know, study up, keep up with what's current, what's working for other people. That's probably why you're here, right? Be polite but persistent. People get tired of hearing, people will start rolling their eyes at me in meetings after a while, because I always, I never miss the opportunity to bring up, well, we could be, if we were doing continuous integration, then we wouldn't be having this problem. But you don't want to strong arm people too much, because then you just make everybody mad. So you have to be polite about it, but don't give up. Just be persistent. Eventually, people will usually come around. Find your allies on the team. You're probably not the only one that wants to follow best practices. There's probably a number of other people. You can get together and brainstorm what to do. You can find out, maybe if they've been on the team a while and you're new, you can find out why they think the team is not following particular best practices, because usually there are reasons, whether they're good reasons or not. There's always reasons why people are not following best practices. Which brings me to the next thing, is to understand what the real problem is. On that team, the one I've held up as sort of the poster child for what not to do, the one that had all the live site issues and the lab issues and the BVTs failing. When me and this other guy worked pretty closely together, and we started pushing for all this change, and we actually we made a significant difference in the team. They went from 40% churn rate to 11% churn rate. And churn is how many people try it and leave it within the first 2 months. And so they went down considerably after we improved the service. How about that? But we got a lot of pushback from a lot of people. There were people fighting us at every turn, and it took me a while in stepping back and getting some perspective on it to figure out what the problem was. And one of the problems was the guy that was in charge of releases had a lot of power on his team, and he liked getting up at 4 o'clock in the morning on Christmas morning to go support a live site issue because he got rewarded for it. He had been rewarded his entire team for putting, for always being there, for putting in a gazillion hours, for sacrificing home and family life. He always got major kudos for having his heart in the right place and being there for the company. But really, and what it turned out is when we took that away from him, he had no crisis anymore to manage. We fixed his crisis, and he didn't like that at all. He was unhappy in a non-crisis situation. Most of the team was a lot happier now that they weren't working so many hours. But he was no longer the center of attention and driving the show. So it was interesting for me to finally have that revelation. It's like, oh, that's why things have happened the way they have. Another thing you need to do is, if you want to get better, you need to measure yourself. You need to figure out where you're at right now, no matter how bad that might be. So measure not only your software, but measure your practices. You can actually make a list of best practices. Are we doing continuous improvement? How do our BDTs pass 100%? How many days in a row can we get 100% BDTs passing? What's our statistic on these things? And then, after you measure yourself, then obviously you take a look at where you are and you set clear goals. What's your biggest pain point? You look at your measurement. Okay, how do we want to fix it? You set a goal, and then of course you want to celebrate your successes along the way. And most importantly, don't give up, because I've been on quite a few different teams that started out in pretty dismal shape, and eventually, little by little, you make changes, they build on each other, and eventually you can build a world-class software development team. And that's it. So I probably should come up with a really good ending tagline. I haven't gotten that far yet. I'll take suggestions for an ending tagline. So, any questions?
I have a question about emulators and simulators. So, you said you use them during the BBT. So on a project, when you start integrating, because what I've come to realize, and what I've found in other companies I worked at, is that by the time they get to the integration piece, the information they've gotten from the team that they're supposed to be integrating with is wrong, is off, is backwards, is totally incomplete.
Right.
Data doesn't work, whatever it is, and it just causes more churn and more problems as soon as they hit that integration piece. So, what are your solutions for something like that?
Well, you want to communicate as much as possible, and I would recommend try to start integrating as quickly as possible, as early as possible, even if you know that it's just a little bit now, and then touch base on a regular basis.
That can also be used as an attribute or benefit to you as well, because knowing that, your developers should probably put the right kind of error handling in place in case the third-party component is not going to behave right. And so, then you actually can then file perhaps a bug on another team and let them know heads up that their system's not providing the right output because you caught it in your system.
So basically I have the same question, and to go on from there, when you said emulators, are you talking stubs and mocks and or something else? What percentage of those are stubs versus mocks, or the other thing that we may talk about? And what level are you applying that kind of testing? In other words, are you doing this at integration? Are you doing this at component level? Is there a mix? What's the mix?
Usually it's a mix and it's situational. So
So
it
there's
depends
no-
upon what you need the emulator for. Is it, replacing a service provided by an entire partner? Or is it just replacing a little module that?
So would you say that begins right after unit test?
I mean, you can do it in conjunction, unit testing doesn't end, it kind of happens throughout the life of the project. My recommendation is, start building your emulators as early in the project as possible, because you'll get the most value out of them.
And is that something other than stubs and mocks, or?
No, pretty much.
Okay, and what percentage
For
would you?
sinks.
Yeah, just off the top
That's
of
all
your,
you
yeah,
need.
sure. Off the top of your head, what percentage of mocks versus stubs?
I couldn't tell you. I'm sure that that's probably project by project basis. Yeah.
I've worked on a team with BBTs where we did not use emulators generally because we couldn't emulate the actual behavior of our external dependencies realistically enough. And plus the external dependencies are changing also. So that would be a reason not to have emulators. But of course the downside was that we had intermittent failures and race conditions and stuff. And then I came up with a strategy for eliminating one-off failures and trying to correlate that as well.
Yeah, the team that I was on that had all the BBT failures and the emulators helped get rid of the partner portion of that. We ended up with 2 dependencies that we didn't build emulators for. One, it was a component that was going to go away in 6 or 8 months, so why put in the effort? We just live with that failure for 6 or 8 months. The other was because it was an extremely complicated component that changed on a regular basis, and we didn't think we could adequately emulate it. And the other part of that was that particular team that built that service actually kept their integration environment very clean, so we almost never failed for them. So we lived with that one as well. It wasn't worth our effort to build that particular emulator. So, yeah, it's all situational, like most things.
And I was going to say also, but if you own the least dependent component rather than it being external dependency, then maybe if you can manage this, lend some devs over there to get this going first and have your unit test and your business logic test, so that then you can move on and do more meaningful testing of the other components.
Anything else?
You might go into the slides just real quick, just.
Sure. I think usually they have a drawing or something, but I don't know where our part of. We miss John Bach.
We all miss John Bach. He still is, we just don't get to see him or talk about him for another years.
The entire presentation, by the way, will be on Quardev site.
So I'm going to let anybody that wants to leave can leave. But if I had a request to look through the slides again.
No, I don't need you to talk about